Hello, in this lecture we'll prove Stewart's theorem in two different methods. In a nutshell, Stewart's theorem yields a relation between the lengths of the sides in the triangle to the length of its serial. So we have here triangle ABC. The length of side AB is C units, side AC equals to B units in its length, side BC equals to A units in its length, line segment BD equals to M units, and line segment DC equals to N units in its length, and the serial in this triangle ABC, is line segment AD, and the length of the serial AD is D units. Repeat again that Stewart's theorem yields a relation between the lengths of the sides in the triangle to the length of its serial. And according to Stewart's theorem, B squared M plus C squared N equals to A. We open the brackets, inside the brackets we have D squared plus M times N. Again, B squared M plus C squared N equals to A. Inside the brackets we have D squared plus Mn. We prove that this equation is true in two different methods. In the first method, we will do a construction from the vertex A. We draw perpendicular to BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as E. We also define the length of this line segment ED as X. We define the length of side or line segment AE as H. And what is the length of line segment BE? From the drawing it is very easy to see that the length of this line segment BE is equal to BD minus ED. Again, BD minus ED equals to BE. I'll write it down. BE equals to BD minus ED. So BE equals to BD equals to M units. So we substitute BD by M minus ED equals to X, so we substitute ED by X. In conclusion, we found out that the length of this line segment BE is M minus X. So I'll write it down. The length of this line segment BE equals to M minus X units. And what is the length of this line segment AC? Although it is very easy to see that EC equals to ED plus DC. ED is X, DC is N, so for EC, in total equals to X plus N. So we write down that EC, this line segment EC, equals to X plus N units in its length. EC equals to N X plus N units. In the next step, we implement the Pythagoras theorem on the right triangle AD. Repeat again. We implement the Pythagoras theorem on the green right triangle triangle AD. Okay. Here by PT is a evaluation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, the hypotenuse in the right triangle AED is AD, therefore the square of the hypotenuse is AD square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AE square plus ED square. Repeat again. In the right triangle AD, according to the Pythagoras theorem, AD square equals to AE square plus ED square. The hypotenuse AD equals to 2 units in its length, therefore AD square is D square and it is equal to AE square. AE equals to h units in its length, therefore AE square equals to h square plus ED square. ED equals to x, ED equals to x, therefore ED square is x square. So actually, in conclusion, we found out that in the right great triangle AED, D square equals to h square plus x square. Okay. In the next step, we will implement the Pythagoras theorem. On the right triangle AEC. This is the right triangle AEC. Repeat again, by PT is evaluation for Pythagoras theorem. In the right triangle AEC, according to the Pythagoras theorem, AC square equals to AE square plus EC square. Repeat again, in the right triangle AEC, according to the Pythagoras theorem, AEC square equals to AE square plus EC square. This is the question number 1. So, the hypotenuse AC equals to B, therefore AC square is B square. And it is equal to AE square. AE is 8, therefore AE square is 8 square plus EC square. EC equals to x percent. X percent according to what we have already found out, therefore EC square equals to x percent square. In conclusion, we found out that in the right triangle AC, b squared equals to a squared plus x plus n squared. Here we'll open the brackets of this side of equation number 1, and we get that according to this equation number 1, b squared equals to h squared plus x plus n squared equals to x squared plus n squared plus 2 times xn. In this equation number 1, we have h squared plus x squared. We have already found out that h squared plus x squared equals to d squared. Therefore, we substitute h squared plus x squared in this equation number 1 by d squared. We do it now, and we get that b squared equals to h squared plus x squared is d squared plus n squared plus 2 times xn. Okay, this is equation number 1. In the next step, we implement the Pythagoras theorem on the right triangle AEB. This right triangle AEB, we implement the Pythagoras theorem on the right pink triangle AEB. This pink right triangle AEB. On the right pink triangle AB, according to the Pythagoras theorem on the right pink triangle AEB, AB squared equals to AE squared plus BE squared plus BE squared. Repeat again, the right pink triangle AEB according to the Pythagoras theorem, AB squared equals to A squared plus BE squared. This is equation number 2. So here AB equals to C, therefore AB squared equals to C squared, and it is equal to AE squared. AE is h, therefore AE squared is h squared plus BE squared. BE equals to n minus x, according to what we already found out, that therefore BE squared equals to n minus x squared. In conclusion, we found out that according to equation number 2, c squared equals to h squared plus n minus x squared. we'll open the brackets on this side of equation number 2. This equation number 2. And we get that according to equation number 2, c squared equals to h squared plus m minus x squared, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab, we get that a minus x squared equals to m squared plus x squared minus 2mx. So in this equation number 2, we have h squared plus x squared. We already found out that h squared plus x squared equals to this square, so we substitute h squared plus x squared in this equation number 2 by this square. We'll do it now, we get that c squared equals to h squared plus x squared is this square plus m squared minus 2 times mx. This is equation number 2. And we have already found out that according to equation number 1, b squared equals to d squared plus n squared plus 2 times xn. Okay. In the next step, we'll create equation number 3. And according to equation number 3, equation number 3 will be created according to the following steps. We will multiply equation number 1 by m. Then we will multiply equation number 2 by n, and then we will add the two equations together. This will be equation number 3. Okay. So in the first step, we will multiply the right side of equation number 1 by m. This is the right side. We multiply the right side of equation number 1, we will multiply it by m. And then we will multiply the right side of equation number 2. This is the right side of equation number 2. We will multiply it by n. And then we will add the two equations together. And this must be equal to the multiplication of the left side of equation number 1 by m plus the multiplication of the left side of equation number 2 by n. Okay? So, first of all, we multiply the right side of equation number 1 by m. This is the right side of equation number 1, we multiply it by m. So it is m, inside the brackets we have d squared plus n squared plus 2 times xn, and then we multiply the right side of equation number 2 by n. So it will be n, this is the right side of equation number 2, so inside the brackets we will have d squared plus m squared minus 2 times mx. Okay, and this must be equal to the multiplication of the left side of equation number 1 by m. In the left side of equation number 1 we have b squared, therefore it will be equal to mb squared plus the multiplication of the left side of equation number 2 by n. In the left side of equation number 2 we have c squared, so it will be nc squared. Okay. In the next step, we will open the brackets on this side of equation number 3. And we will get that according to equation number 3, m times d square is md square, plus m times n square is mn square, plus m times 2xn is 2xmn, plus also we'll open the brackets of this expression. So n times d square is nd square, plus n times m square is nm square, plus n times minus 2mx is minus 2mxn. So actually, this is equation number 3 after we open the brackets. So here we have 2xmn plus 2xmn minus 2xmn is 0. So those two expressions will get cancelled. What is left from equation number 3 after we cancel the two expressions? We have md square plus mn square plus nd square plus nm square here. I didn't copy the right side of equation number 3. In the right side of equation number 3 we have mb square plus nc square equals to mb square plus nc square. So also here is equals to mb square plus nc square. In the next step, we will take this square out as a common factor of md square and as a common factor of nd square. What is left from md square after we took from it m as a common factor? What is left is m. What is left from nd square after we took from it d square as a common factor? What is left is actually n. And we will also take mn out as a common factor from this expression and from this expression. So what is left from nm square after we took from it nm as a common factor? What is left is actually m, plus what is left from mn square after we took from it mn as a common factor? What is left is actually n, and it is equal to mb square plus nc square. The next step, we will take m plus n out as a common factor from this expression and from this expression. So what is left from this expression after we took from it this m plus n as a common factor? What is left is actually d square. What is left from this expression after we took from it m plus n as a common factor? What is left is actually mn, and it is equal to b square m plus c square n. m plus n equals to a. It's very easy to see it in the drawing. The length of side BC of triangle ABC is a units from one side. From the other side, it is very easy to see that BC equals to BD plus DC. So BC equals to BD, that is M, plus DC, that is N. So BC equals to M plus N from the other side, and from one side, and from the other side it is equals to A. Therefore A equals to M plus N. A equals to M plus N. So we substitute M plus N in this equation number 3 by A, and we get that A, inside the brackets we have D squared plus M times N equals to B squared M plus C squared N. And this is exactly the Stewart's theorem. Okay, so we proved Stewart's theorem. The first method. In the next step, we'll prove Stewart's theorem in a different method. We'll prove Stewart's theorem. The second method. Here, in the second method, we define angle ADB. This angle is theta. Therefore, the adjacent angle ADC must be equal to 180 degrees minus theta. According to the rule that the sum of the rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. BC, side BC is absolutely a straight line. So on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at the upper side of BC at point D? We have this angle that is theta plus the missing angle ADC. Total they must be equal to 180 degrees according to rule number 1. So the missing angle ADC must be equal to 180 degrees minus theta. Why? Because in total 180 degrees minus theta plus theta equals to 180 degrees, exactly according to rule number 1. In the next step, we'll implement the law of cosines in the green triangle ABD. This green triangle. And then we implement the same law, the law of cosines, in the pink triangle ADC. I will remind you shortly, quickly, what is the law of cosines. Actually, the law of cosines is true in any triangle. According to the law of cosines, here triangle ABC could be any triangle. We know that the length of side AB is A units, side AC equals to B units in its length, side BC equals to C units in its length, and this angle BAC equals to theta. Then according to the law of cosines, C square equals to A square plus C square equals to A square plus B square minus 2 times AB times cosine theta. Okay? If we add to this equation 2 times AB cosine theta, then we subtract C square, then we divide this equation by 2 times AB, we'll get that cosine theta equals to A square plus B square minus C square over 2 times AB. Okay? It's very easy to arrive from this equation to this equation. Okay, so we implement the law of cosines in the green triangle ABD. And according to the law of cosines, in the great triangle ADB, in the great triangle ADB, according to the law of cosines, cosine theta equals to d squared plus m squared minus c squared over 2 times dm. So actually this equation number 1, cosine theta equals to d squared plus m squared minus c squared over 2 times dm is the implementation of the law of cosines in the great triangle ADB. In the next step, we will implement the law of cosines in the pink triangle ADC. Okay. So, according to the law of cosines in the pink triangle ADC, we will get that cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times d times n. So this equation number 2 is the implementation of the law of cosines in the pink triangle ADC. Okay, we have the trigonometric identity that cosine 180 degrees minus theta equals to minus cosine theta. So according to this trigonometric identity, we substitute cosine 180 degrees in this equation number 2 by minus cosine theta. Okay. And we get that according to this equation number 2, minus cosine theta equals to d squared plus n squared minus b squared over 2 times dn. This is equation number 2. In the next step, we will multiply this equation number 1 by minus 1. And we'll get that cosine theta times minus 1 is minus cosine theta. And it is equal, we'll multiply the other side of course by minus 1 also, so it will be minus. Inside the brackets we have d squared plus m squared minus c squared over 2 times d times m. So we have two different equations for the value of minus cosine theta. Therefore we'll create equation number 3 that states that minus cosine theta, according to equation number 1, must be equal to minus cosine theta according to equation number 2. That is to say, minus cosine theta according to equation number 1 equals to minus d squared plus m squared minus c squared over 2 times d times m, and it must be equal to minus cosine theta according to equation number 2, and minus cosine theta according to equation number 2 equals to d squared plus n squared minus b squared over 2 times d times n. In the next step, we will multiply this equation number 3 by 2d. So in this side of the equation we have 2d over 2d is 1, so 2d will get cancelled. So in the denominator of this side of equation number 3 we left only with m, and the numerator didn't change. That is to say, we have here the same expression, that is minus d squared plus m squared minus c squared equals to, we multiply this side of equation, the other side of equation number 3 here by 2d, so 2d over 2d is 1, so 2d will get cancelled. In the denominator of this expression we left only with n, and the numerator didn't change. It is the same expression, that is to say it is d squared plus n squared d squared plus it is actually d squared plus n squared minus b squared. Okay. In the next step, we'll cross multiply this equation number 3, and we get that according to equation number 3, minus n, inside the brackets we have d squared plus m squared minus c squared equals to m, inside the brackets we have d squared plus n squared minus b squared. So actually this is equation number 3 after we cross multiply it. In the next step we'll open the brackets on both sides of this equation number 3, and we'll get that minus n times d squared is minus n d squared minus n minus n times m squared is minus nm squared. And finally, minus n times minus c squared is plus nc squared. Why? Because minus times minus is plus. And it is equals to m times d squared is md squared plus m times n squared is mn squared. M times minus b squared is minus mb squared. So in the next step, we will add to this equation number 3, nd squared. So in this side of equation number 3, nd squared plus nd squared is 0. And we also add to this equation number 3, nm squared. So in this side of equation number 3, we get that nm squared minus nm squared is 0. And we subtract nc squared. So here in this side of equation number 3, we have nc squared minus nc squared is 0. So in this side of the equation in total, we have 0. In the other side of the equation number 3, we already have the expression md squared plus mn squared minus mb squared, and we have to add to this equation number 3, nd squared, this side of equation number 3. We have to add also to this side of equation number 3, nm squared, and we have to subtract from this side of equation number 3, nc squared. Okay. In the next step, we take out this square as a common factor of md squared and also as a common factor of nd squared. So what is left from md squared after we took from it this square as a common factor? What is left is m. What is left from nd squared after we took from it this square as a common factor? What is left is actually n. And we will also take out mn as a common factor of mn squared and also as a common factor of nm squared. Okay. So what is left from nm squared after we took from it mn as a common factor? What is left is actually m. What is left from mn squared after we took from it mn as a common factor? What is left is actually n. And we also have here minus mb squared minus nc squared equals to 0. The next step we add to this equation number 3, mb squared, and also we'll add to it nc squared, and we'll get that d squared m plus n plus mn m plus n. So mb squared minus mb squared is 0, nc squared minus nc squared is 0. In the other side of the equation we will have to add mb squared and also nc squared. In the next step we'll take m plus n out as a common factor from this expression and also from this expression. So what is left from this expression we took from it m plus n as a common factor. What is left is actually d squared, and what is left from this expression after we took from it d squared as a common factor? What is left is actually mn, and it is equal to b squared m plus c squared n. Actually, we have already found out that in the first method, we already found out that m plus n equals to a, therefore we can substitute m plus n in this equation number 3 by a. We do it now and we get that according to equation number 3, m plus n is a. Inside the brackets we have d squared plus mn, and it is equal to b squared m plus c squared n. Okay, and this is exactly Stewart's theorem. So we proved Stewart's theorem in two different methods. In the next step, I'll summarize the lecture. We'll start with the first method. In this lecture, we proved Stewart's theorem in two different methods. In a nutshell, Stewart's theorem yields a relation between the lengths of the sides in the triangle to the length of its CVN. Okay? And according to Stewart's theorem, this triangle ABC, side AB is C units, side AC equals to B units in itself, and side BC equals to A units in itself. In addition, line segment BD equals to M units, and line segment DC equals to N units. And the CVN in this triangle ABC is line segment AD, and the CVN AD equals to D units in its length. Then, according to Stewart's theorem, we get that the following equation is true. That b squared times m plus c squared times n equals to a. A is the length of side BC of triangle ABC. To a, we'll open the brackets. Inside the brackets we have d squared plus m times n. Again, b squared m plus c squared n equals to a. Inside the brackets we have d squared plus mn. So we actually proved this equation in two different methods. In the first method, we have did the construction from point A. We draw perpendicular on BC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as E. Okay, then we define side AD as X. And we define side line segment AE as edge, and here line segment EC equals to X plus N, and line segment BE, this line segment BE equals to BD minus ED. BD is M, ED is X, so in total BE equals to M minus X. BD equals to M minus X. Then we implemented the Pythagoras theorem on the green right triangle AED. According to the Pythagoras theorem on the green right triangle AED, according to the Pythagoras theorem, the square of the opposite equals to the sum of the squares of the perpendiculars. That is to say, in the right hand triangle AD square equals to AE square plus ED square. Again, the right hand triangle AD square equals to AE square plus ED square. Yeah. AD is D, therefore AD square is D square. AE is edge, therefore AE square is edge square. And finally, ED is X, therefore ED square is X square. So in conclusion, we found out that according to the Pythagoras theorem, D square equals to X square plus X square in the right hand triangle AD. Then we implemented the law of the Pythagoras theorem on the right triangle, triangle AEC. According to the Pythagoras theorem on the right triangle, triangle AEC, AC square equals to AE square plus EC square. Again, AC square equals to AE square plus EC square. Repeat again, in the right triangle AEC, AC square equals to AE square plus EC square. AC is B, therefore AC square is B square. AE is X, therefore AE square is X square. EC is X plus N, therefore EC square is X plus N square. In conclusion, found out that according to equation number 1, B square equals to S square plus X plus N square. Here we open the brackets on this side of equation number 1, and we found out that according to equation number 1, B square equals to S square plus X square plus X plus N square equals to X square plus N square plus 2 times Xn. In this equation number 1, we have X square plus X square, and according to this equation, H square plus X square equals to D square. So we substitute D square in this equation, we substitute H square plus H square in this equation number 1 by D square. And we got that B square equals to D square plus N square plus 2 times Xn. Then we implemented the Pythagoras theorem on the right pin triangle, triangle AEB. According to the Pythagoras theorem, in the right pin triangle, triangle AEB, AB square equals to AE square plus EB square. Again, AB square equals to AE square plus EB square. Repeat again, in the right pin triangle AEB, AB square equals to AE square plus EB square. AB is C, therefore AB square is C square. AE is H, therefore AE square is H square. And finally, BE, we already found out that BE equals to M minus X here. Therefore, BE square is M minus X square. BE square is M minus X square. And so in conclusion, found out that according to equation number 2, C square equals to S square plus M minus X square. In the next step, we open the brackets on this side of equation number 2 and found out, before that, we opened the brackets here and we found out that C square equals to H square, M minus X square according to the algebraic identity that A minus B square equals to A square plus B square minus 2 times AB. We get that M minus X square equals to M square plus X square minus 2 times MX. In this equation number 2, we have H square plus X square, H square plus X square equals to D square. We substitute H square plus X square by D square and found out that C square equals to D square plus M square minus 2 times MX according to equation number 2. But according to equation number 1, we already found out that B square equals to D square plus N square plus 2xn. Then we created equation number 3. According to equation number 3, we created equation number 3 according to the following steps. In the first step, we multiplied the equation number 1 by m. In the second step, we multiplied the equation number 2 by n. And in the third step, we added the two equations together. This created equation number 3. We did it in 2 steps. First of all, we multiplied the right side of this equation number 1 by m. This is the right side. We multiply it by m. So it is m. Inside the brackets we have d square plus n square plus 2 times xn. Then we multiply the right side of this equation number 2 by n. This is the right side of equation number 2, so it is n. Inside the brackets we have d square times d square plus m square minus 2 times mx. Then we added the two equations together, and this must be equal to the multiplication of equation of the left side of equation number 1 by m. This is the left side of equation number 1. Therefore it is m times b square plus the multiplication of the left side of this equation number 2 by n. In the left side of equation number 2 we have c square, so it is nc square. Then we opened the brackets of this side of equation number 3 and found that m times d square is md square, m times n square is mn square, m times 2xn is 2xmn. We also open the brackets of this expression. N times d square is nd square, n times m square is nm square, and finally n times minus 2mx is minus 2xmn. It is equal to mp square plus nc square. So actually, this is equation number 3 after we open the brackets. In this side of equation number 3, we have plus 2xmn minus 2xmn is 0. So those two expressions will get cancelled. And what is left from equation number 3 after we cancel the two expressions? What is left? Actually, mb square plus mn square plus nd square plus nm square equals to mb square plus nc square. In the next step, we took out this square, second factor, from md square and also from nd square. So inside the brackets we left only with m plus n. Plus, then we took out nm, a second factor, from n square and also from n square m. So inside the brackets we left only with m plus n, and it is equal to mb square plus nc square. Then we took out m plus n, a second factor, from those two expressions. So inside the brackets we left only with d square plus mn. It is equal to b square m plus c square n. We have only it is very easy to see in the drawing that m plus n equals to a. Here, m plus n on one side, bc equals to m plus n. From the other side, it is equal to a. Therefore, m plus n equals to a. So we can substitute m plus n in equation number 3 by a. We did it, and we found out that here m plus n is a. Inside the brackets we have d square plus mn equals to b square m plus c square n, and this is exactly the Stewart's equation. Then we put Stewart's equation according to the second method. In the second method, we define this angle as theta, therefore this angle must, the adjacent angle must be equal to 180 degrees. Minus theta according to rule number 1, the sum of the angles on one side of the straight line is equal to 180 degrees. Then we implemented the law of cosines in the green triangle and then in the pink triangle. What is the law of cosines? The law of cosines is true in any triangle. So this triangle ABC could be any triangle. In this triangle ABC, side AB equals to A, side AC equals to B units in itself, and side BC equals to C units in itself. This angle BAC equals to theta. According to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine theta. Then it is very easy to get from this equation to this equation that cosine theta equals to A square plus B square minus C square over 2 times AB. So we implemented the law of cosines in the green triangle, triangle ABD. According to the law of cosines in the green triangle, triangle ABD, cosine theta equals to d square plus m square minus c square over 2 times d times m. I repeat again, in the green triangle, triangle ABD, according to the law of cosines, cosine theta equals to d square plus m square minus c square over 2 times dm. Likewise, we implemented the law of cosines in the pink triangle, triangle ADC. The pink triangle, according to the law of cosines, cosine under 80 degrees minus theta equals to d square plus n square minus b square over 2 times d times n. I repeat again, in the pink triangle ADC, according to the law of cosines, cosine under 80 degrees minus theta equals to d square plus n square minus b square over 2 times d times n. We have the trigonometric identity that cosine minus under 80 degrees equals to minus cosine minus 180 degrees minus theta equals to minus cosine theta. So we substitute cosine 180 degrees minus theta in this equation, equation number 2, by minus cosine theta, and we got that minus cosine theta equals to d squared plus n squared minus b squared over 2 times dn. Okay, this is equation number 2. Then we multiply this equation number 1 by minus 1. Cosine theta times minus 1 is minus cosine theta. And we also multiply this side of equation number 1 by minus, so it is minus. Inside the brackets we have d squared plus m squared minus c squared over 2 times dn. So we have two different expressions for minus cosine theta. Therefore, we created equation number 3 that states that minus cosine theta according to equation number 1, it must be equal to minus cosine theta according to equation number 2. So minus cosine theta according to equation number 1 equals to d squared plus m squared minus c squared over 2 times dm, and it must be equal to minus cosine theta according to equation number 2. Minus cosine theta according to equation number 2 equals to d squared plus n squared minus b squared over 2 times dn. Then we multiply this equation number 3 by 2d. 2d over 2d is 1, so in the denominator we left only with m. The numerator didn't change, so it is minus d squared minus, inside the brackets we have d squared plus m squared minus c squared. We also multiply this side of equation number 3 by 2d. 2d over 2d is 1, so in the denominator we left only with n. The numerator didn't change, it stays as d squared plus n squared minus b squared. Then we cross multiply this equation number 3, and we got that minus n d squared plus m squared minus c squared equals to m. Inside the brackets we have d squared plus n squared minus b squared. Then we open the brackets on both sides of this equation number 3. Minus n times d squared is minus n d squared, minus n times m is minus n m squared, and finally minus n times minus c squared is n plus n c squared, because minus times minus is plus. We open the brackets of this side of equation number 3 also. M times d squared is m d squared, m times m n squared is m n squared, and finally m times minus b squared is minus m b squared. Then we added to this equation number 3 n d squared. So in this side of equation number 3, n d squared minus n d squared is 0. We added also to this equation number 3 n m squared. So in this side of equation number 3, n m squared minus n m squared is 0, and we subtracted from this equation number 3 n c squared. So in this side of equation number 3 we have n c squared minus n c squared is 0. So in total this side of equation number 3 we left with 0. And the other side of equation number 3, we only add the expression md squared plus nm squared minus mb squared, and we have to add to this equation mb squared and also nd squared, and we have to subtract from this side of equation number 3 nc squared. Okay, then we took out d squared second factor from md squared and also from nd squared, so inside the brackets we have left only with m plus n. Then we took mn as second factor from mn squared and also from nm squared, so inside the brackets we left with m plus n. It is minus m, and also we have here minus mb squared minus nc squared. The next step we added to this equation mb squared plus nc squared, and we found out that this squared plus times m plus n plus mn times m plus n equals to mb squared plus nc squared. Then we took out m plus n as second factor from those two expressions, so inside the brackets we left only with d squared plus nm, and it is equal to b squared n plus c squared n. We have already found out that in the first method that m plus n equals to n, so we substitute m plus n in this equation number 3 by a, and we found out that m plus n is a. Inside the brackets we have d squared plus mn equals to b squared n plus c squared n. And this is exactly the equation of Stewart's theorem. So we succeeded to prove Stewart's theorem in two different methods. Okay, thank you very much.